Okay, let's now talk about another concept called power. What is the meaning of power? Very often children fight against each other saying, "Oh, I am more powerful." Now, how do you judge the power of a person? Well, if two boys compete, we can say, "All right, I want to see how long you take to jump upstairs." Now you got the stairs going up. So the first boy goes up. I time him. He takes 6 seconds. And the second one tries. He takes 8 seconds. Now, who is more powerful? You see, if a person is more powerful, that person can do the same amount of work in less amount of time. You see? So, how do we define power? Power is the rate of doing work. The rate at which work is done is called power. And you can calculate power as work done divided by the time taken. What is the unit for measuring power? Work is measured in joules. Time is measured in seconds. Therefore, power is measured in joules per second, and joules per second is called a watt, and we represent that by the uppercase W. Now, notice all these are very important concepts. So, what is the unit for measuring power? Power is the rate of doing work. It is measured in joules per second. And a joule per second is called a watt. So the unit of power is the watt. Tell me, you have a 60-watt bulb in your bedroom. What does that mean? 60 watt. It means that bulb will use up electrical energy at the rate of 60 joules per second. That is why it is called a 60-watt bulb. 100 watt is 1 kilowatt. Since power is the rate of doing work, we can say power is delta W divided by delta T, dW by dt, the rate of doing work. Power is the rate of doing work. If power is dW by dt, the derivative of W with respect to time, let's replace W by F dot x, force multiplied by the displacement. You get power equal to the d by dt of F dot x. Well, if F is a constant, if the force remains a constant, I can take it out. That will be F times dx by dt. And what is dx by dt? Dx by dt is the velocity. Is that right? So power is force multiplied by velocity. You can do that either work divided by time or force multiplied by velocity. You can also rewrite right from here without going through calculus. And that is power work done is force multiplied by the displacement. Divide that by time. And that will be force multiplied by x over t. What is x over t? Displacement divided by time is the average velocity. So force multiplied by average velocity is a measure of the average power. That will be force multiplied by velocity. These are very useful concepts. Average power is force multiplied by average velocity. Okay. we can actually use these concepts to solve problems. Let's do a small problem. A 1500 kilogram race car can go from 0 to 90 kilometers per hour in 5 seconds. What is the average power required to do this? Well, we have V0, initial velocity is 0, the final velocity is 90 kilometers per hour. Convert that to meter per second, divide by 3.6. That gives you the final velocity is 25 meters per second. The time taken is 5 seconds and the mass of the race car is 1500 kilograms. That is our data. First of all, we find acceleration. What is the acceleration caused by the force producing that acceleration? Acceleration is Vf minus V0 over t, and that gives you 5 meters per second squared. Now, if the acceleration is 5 meters per second squared, and this acceleration is produced on this mass of 1500 kilograms, therefore, can you calculate the force producing that acceleration? The force producing this acceleration is F equal to ma. That will be mass multiplied by the acceleration. That is 7,500 Newton. Now, this is the amount of force that is used in accelerating the car. The average velocity during this 5 seconds. Can you tell me what is the average velocity during this 5 seconds? Because the acceleration is a constant, the average velocity is simply initial velocity plus the final velocity divided by 2. So the average velocity is V0 plus Vf over 2. 0 plus 25 over 2, that is 12.5 meters per second. A force of 7,000 Newton applied on the car gave it an average velocity of 12.5 meters per second. Therefore, what is the average power required to do this? The average power is force multiplied by the average velocity. The average power is force multiplied by the average velocity. That will be 9.375 times 10 to the 4 watt, or which will be 93.75 kilowatt. All right, let's do another problem. A 1500 kilogram elevator accelerates upward at a constant rate of 0.5 meter per second squared. How much power is developed on an average during the time the elevator's speed increases from 0.25 meter per second to 0.75 meter per second? Here again, we have the initial velocity, final velocity, we can find the average velocity. And we have the mass of the elevator, we have the acceleration of the elevator, we can calculate the force that is producing that acceleration on the elevator. First, we find the force required to produce this acceleration of 0.5 meter per second squared upward. Well, that's not difficult. F equal to, now you must understand that the force applied first has to overcome the weight of the elevator, which is downward, and then it has to produce the acceleration upward. Is that right? So the total force required to do that is F equal to mg plus ma. We have actually done that in a former lesson. In order that the elevator may be given an upward acceleration of 0.5 meter per second squared. First of all, the weight of the elevator need to be overcome. So you need to apply a force equal to the weight of the elevator first. Now, once that force is applying upward, the elevator is now ready to move up. And then the additional force required is mass times acceleration. So the total force that is needed to accelerate the elevator upward is mg plus ma, that is 15,450 Newton. It is this force that is doing the work in this case. The initial velocity is 0.25 meter per second. The final velocity is 0.75 meter per second. Therefore, the average velocity is v0 plus vf over 2. That is 0.5 meter per second. And so, what is the power developed for this purpose? Power developed is the force multiplied by the average velocity. This is the force, this is the average velocity. Therefore, the average power is 7,725 watt, which is 7.725 kilowatt. I hope this concept of power connected to average velocity is clear to you now. Well, that will be the brief description of work and power. Well, always remember, when you listen to the lecture, consolidate that understanding by doing the homework. And only by doing the homework you will learn the concept. Alright, I will see you for the next lesson in this unit later on.